So in the previous video, we have discussed about clustering and the basic formation for the clustering working. In this video, we are going to discuss about the common types of clustering in which we say uh, the further algorithms are based. So clustering we know is the process of finding a set of clusters based on the similarity. So if we talk of the two important types of clustering, then they are hierarchical and partitional. So when we talk of partition clustering, which is a division data objects into a non-overlapping clusters that each other object is exactly a one subset, that we are dividing something into different partition, different groups. So that is a partition. Making the partition is a partition clustering. And hierarchical clustering is not just like having a tree-like structure where we form a dendrogram in the case, and a set of nested clusters organized is a hierarchical tree is known as hierarchical cluster. We have density based clusters also that discover clusters of arbitrary shape in which we are able to form different types of shapes. Then they are density based clusters. So clusters dense regions of objects are separated by regions of low density. This is an example of partition clustering where we can say certain original points are there, and based on that we have done the partitioning. We have divided them into two groups like this one and this one. So here this is example of partitional clustering, and this is the hierarchical clustering where it works like this, in which we are having certain points which are being organized, or we can say, we suppose I have a point A, B, C, D, E, F, G. So now suppose we are having these points. In this say we can say these points look very together, so we will form it as a one cluster, and we will represent these 2 points and link them in a one cluster. So in this case we can see for the C and D, so they are at the same level, so it will be formed something like this, C and D. And now similarly we are having E and F that can directly go into a one cluster, so forming this E and F. Now here is a G cluster also, so we know that this G is closest to the EF, so we form it like this, EFG. So here we will use the point G and it will be linked with this. Now further on it will find the next closest distance, like suppose these all can be combined into a single cluster, or before forming this cluster is closest to this one, so it will be forming like this, and then further the common cluster it will be drawn like this. So this hierarchy is drawn, which is known as a dendrogram. So if we work on this type of technology, traditional hierarchical clustering or non-traditional hierarchical clustering, in which we are forming a dendrogram and it is represented in the form of a dendrogram, is a type of hierarchical clustering. So density based clustering are like this, where these are the points. We can clearly see these points are too dense in this case, so one cluster will be formed for this. So again we can see these look like having same dense points, so one density based cluster here, and similarly this one. So these are represented into different colors over here. So this where we are working on the density level or sparse level of something. So there is sparsity between these but these points are too dense to each other. So if this type and we are able to form different type of shapes, so in this case this is known as density based clusters. So when we talk of various aspects of clustering, we have main clustering algorithms as partitional clustering and hierarchical clustering. A distance matrix is used, distance function is used to calculate the similarity or the dissimilarity between them. So for that we use the basic function, that is the Euclidean distance, or we can use the Manhattan distance. Talking of these two distances, the formula to calculate Euclidean distance is x2 minus x1 square plus y2 minus y1 square, and we take the square root of this. So this is the Euclidean distance, which gives the distance measured between 2 points. So how it is working, suppose we are having xy, x2 and y2. One data point is x1, y1, another data point is having dimension x2, y2, where suppose we can say X is height of person, Y is weight of person. So similarly, this is height and weight of first person, height and weight of second person. We want to form the cluster, then we take the Euclidean distance. And when we talk of Manhattan distance, it is nothing else. It is formed with the absolute value uh, this way. So here we don't take the square root, we simply take the absolute value of the differences. Then in that case, that is known as the Manhattan distance. So when we are working on any of type of partitional algorithm, clustering algorithm, it may be agglomerative clustering, which is a type of partition hierarchical clustering, or we can say k-means or k-midwives clustering, which is a type of partition clustering. We can use this Euclidean and Manhattan distance to calculate the similarity or dissimilarity. So the clustering quality, we have inter-cluster distance is maximized and intra-cluster distance is minimized. The quality of clustering results simply depends on the algorithm, the distance function, and the applications. So using the classification model, we can do the categorization of these based on certain similarity functions. So we have other types of clustering algorithms which are not in much use. Hierarchical methods, where in hierarchical we get agglomerative and divisive algorithms, which is further categorized into types. And similarly, we are having partitional methods, in which we have relocation, probabilistic algorithm, k-midwives, k-means methods, and we also have the density based algorithms, in which density weight connection clustering or density function based clustering is also there. We have grid based methods. We have clustering algorithms used in machine learning, like gradient descent and artificial neural networks. Evolutionary methods, we have also have algorithms for high dimensional data, in which we have subspace clustering, projection techniques, and co-clustering techniques. So we will be discussing about hierarchical methods, agglomerative and divisive algorithm in detail in the coming videos. We will also discuss into detail about the partitional algorithms like k-means and k-midwives algorithms. So for those videos that you should not miss, must not miss those videos, because we will be solving the numerical examples for all those algorithms also. So if you have not subscribed my channel yet, do subscribe it so that you don't miss those important videos. So thanks for watching the video.